Hello everyone. This lesson is about solving quadratic inequalities. Example number 1. Solve x squared minus 10x plus 25 is less than 0. Our quadratic trinomial here is a perfect square trinomial. Why? It's because our first term x squared is a perfect square. Our last term 25 is also a perfect square, and the middle term is twice the square root of the first term times the square root of the last term. So the square root of the first term x squared is x, the square root of the last term 25 is 5, so 2 times x times 5 equals 10x, which is our middle term. So the sign of the middle term can either be positive or negative. So this means if we have x squared plus 10x plus 25, it is still a perfect square trinomial. Since it's a perfect square trinomial, it can be expressed as square of a binomial. So how? The square root of x squared is x, the square root of 25 is 5, and the sign of the middle term is negative, so we can express this as the quantity x minus 5 squared. Now, if this would be the case, the square of a binomial is less than 0. Less than 0 means negative, so there is no solution. Why? Because when we square a value, any number, it can never be a negative number. How about if we are going to change this less than to less than or equal to? We will make it our example number 2. Now we know that this is a perfect square trinomial, and it can be expressed as the quantity x minus 5 squared is less than or equal to 0, and we already know that it has no solution if it is just less than 0. So we will solve for our inequality using the equal sign. So we have the quantity x minus 5 squared equals 0. Now, to get rid of this square here, we are going to get the square root of both sides, so it becomes x minus 5 equals 0. Adding 5 on both sides, we have x equals 5. So for this inequality, x squared minus 10x plus 25 is less than or equal to 0. Our value of x here is 5. Example number 3. Solve x squared plus 6x plus 9 is greater than or equal to 0. Our quadratic trinomial here is a perfect square trinomial. Why? It's because our first term x squared is a perfect square. Our last term 9 is also a perfect square. And our middle term is twice of the square root of the first term times the square root of the last term. So square root of the first term is x, square root of the last term is 3, so we have 2 times x times 3 equals 6x. Again, the sign of the middle term can either be positive or negative, meaning to say if we have x squared minus 6x plus 9, it is still a perfect square trinomial. Now, since it is a perfect square trinomial, it can be expressed as square of a binomial. So how? Square root of x squared is x, square root of 9 is 3, then the sign of the middle term is positive, so it can be expressed as the quantity x plus 3 squared is greater than or equal to 0. Now, if this would be the case, our solution would be set of all real numbers. Why? Because for whatever value of x we put here, it will always be greater than or equal to 0. If we square a positive number, it will be a positive number. If we square a negative number, it will still be a positive number. And if we square a 0, it will still be a 0. Our answer here is settable real numbers, or from negative infinity to positive infinity. Now, how about if we are going to change this greater than or equal to just greater than? Let's make it example number 4. We know that x squared plus 6x plus 9 is a perfect square trinomial, so we can express our inequality as the quantity x plus 3 squared is greater than 0. Now, we are going to change this inequality sign to equal sign and solve for x. So we have the quantity x plus 3 squared equals 0. To get rid of this square here, we are going to get the square root of both sides. So we have x plus 3 equals 0. Now subtracting 3 from both sides, we have x equals negative 3. So this value, x equals negative 3, we are going to exclude it. So that would mean if we are going to draw our number line, we put our negative 3 here, and we will indicate positive infinity on the right and negative infinity on the left. Because negative 3 is excluded, we are going to put an open circle on it. This means x is less than negative 3, or x is greater than negative 3. We have another way of writing our answer. That's from negative infinity to less than negative 3, union from greater than negative 3 to positive infinity. Example number 5. Solve x squared plus 5x minus 14 is less than 0. Here, our trinomial is not a perfect square trinomial. Why? Because our last term here is not a perfect square. So we can write our trinomial in factored form. So the factors of x squared plus 5x minus 14 are the quantity x minus 2 times the quantity x plus 7. Now, we are going to change this inequality sign to equal sign and solve for x. So we have the quantity x minus 2 times the quantity x plus 7 equals 0. Equating both factors to 0, we have x minus 2 equals 0 and x plus 7 equals 0. Now for our first equation, we add 2 on both sides, so that's x equals 2. And for our second equation, we subtract 7 from both sides, so we have x equals negative 7. Now because our inequality here is less than, so that means we are going to exclude 2 and negative 7 on our solution. Now we are going to draw our number line. We are going to place negative 7 here and positive 2 here. On the right side, we are going to indicate positive infinity. On the left side, we are going to indicate negative infinity. And again, because negative 7 and 2 are not included, we are going to put open circles on them. Now, notice here that these two numbers, negative 7 and 2, divide our number line into 3 intervals. The first one is here, from negative infinity to less than negative 7. The second interval is from greater than negative 7 to less than 2. And the third interval is from greater than 2 to positive infinity. Which of these 3 intervals is or are solutions of our inequality? Now let's try this interval from negative infinity to less than negative 7. We are going to try any number that is less than negative 7. So for example, we are going to try negative 8. Now we are going to substitute all our x's here with negative 8. So that means negative 8 squared plus 5 times negative 8 minus 14 is less than 0. Now simplifying this part, negative 8 squared plus 5 times negative 8 minus 14, that will give us 10. So 10 is less than 0 is false. Meaning to say, this interval here from negative infinity to less than negative 7 is not a solution. Now let's try the second interval from greater than negative 7 to less than 2. So we can try any number that is between these two numbers. So let's try 0. We are going to substitute all our x's here with 0, so that means 0 squared plus 5 times 0 minus 14. And simplifying this part here, 0 squared plus 5 times 0 minus 14, that will give us negative 14. And negative 14 is less than 0 is true. So meaning to say, this interval here is a solution. So this is from greater than negative 7 to less than 2. Now let's try this third interval from greater than 2 to positive infinity. We can use any number that is greater than 2. For example, we will use 3. We are going to substitute all our x's here with 3. So that means 3 squared plus 5 times 3 minus 14 is less than 0. So simplifying this part here, 3 squared plus 5 times 3 minus 14, that gives us 10. So 10 is less than 0 is false. So this interval here is not a solution. So this means our solution is from greater than negative 7 to less than 2. Another way of notating our answer is open parentheses negative 7 comma 2 close parentheses. This means from greater than negative 7 to less than 2. Example number 6. Solve x squared minus 3x is greater than or equal to 10. So first step, we are going to subtract 10 from both sides. So it becomes x squared minus 3x minus 10 is greater than or equal to 0. So next step, we are going to write this trinomial x squared minus 3x minus 10 in factored form and changing the inequality sign to equal sign. So the factors are the quantity x minus 5 times the quantity x plus 2. Now it is equal to 0. Now equating both factors to 0, we have x minus 5 equals 0 and x plus 2 equals 0. For our first equation, we add 5 on both sides, so x equals 5. And for our second equation, we subtract 2 from both sides, so we have x equals negative 2. Now we are going to draw our number line. So we will place these numbers, negative 2 and 5, on our number line. So negative 2 here and 5 here. And then we will indicate positive infinity on the right and negative infinity on the left. Since our inequality is greater than or equal to, that means negative 2 and 5 are included on our solution. So we will have to put closed circles on negative 2 and 5. Now notice here that these numbers negative 2 and 5 divide our number line into 3 intervals. Our first interval is from negative infinity to less than negative 2, and our second interval is from greater than negative 2 to less than 5, and our third interval is from greater than 5 to positive infinity. We are going to try which of these intervals is or are the solutions of our inequality. Now let's try the first interval from negative infinity to less than negative 2. We are going to try any number that is less than negative 2. For example, we will try negative 3. So we are going to substitute all our x's here with negative 3. So that's negative 3 squared minus 3 times negative 3 minus 10 is greater than 0. Now simplifying this part here, negative 3 squared minus 3 times negative 3 minus 10, that gives us 8. And 8 is greater than 0, so it's true. Meaning to say, this interval here is a solution. So, since negative 2 is included, we will say x is less than or equal to negative 2. Now let's try the second interval from greater than negative 2 to less than 5. We are going to choose any number between negative 2 and 5. So for example, we are going to try 0. So we are going to substitute all our x's here with 0. So that means 0 squared minus 3 times 0 minus 10 is greater than 0. So simplifying this part here, 0 squared minus 3 times 0 minus 10, that's negative 10. Negative 10 is greater than 0 is false. So this interval here is not a solution. Now let's try the third interval from greater than 5 to positive infinity. We can choose any number that is greater than 5. For example, let's try 6. We are going to substitute all our x's here with 6. So that's 6 squared minus 3 times 6 minus 10 is greater than 0. Now simplifying this part here, 6 squared minus 3 times 6 minus 10, that's 8. So 8 is greater than 0 is also true. Meaning to say, this interval here from greater than 5 to positive infinity is a solution. Now since 5 is included, so we can write x is greater than or equal to 5. We have another way of notating our answer. It's from negative infinity to negative 2, then union from 5 to positive infinity. Notice here that we use bracket instead of parentheses. So we use bracket if our inequality has the equal to sign. That means less than or equal to, so that's bracket. Greater than or equal to, bracket also. Now, your turn. Solve the following inequalities. Number 1, x squared plus 8x plus 12 is greater than 0. And number 2, x squared minus 9x minus 36 is less than or equal to 0. You can pause the video and take your time solving these two inequalities. Now I will show you the answer. For number 1, our answer is x is less than negative 6, or x is greater than negative 2. And we have another way of notating our answer. From negative infinity to less than negative 6, union from greater than negative 2 to positive infinity. And for number 2, our answer is negative 3 less than or equal to x less than or equal to 12. Or we have another way of notating our answer. So it's from negative 3 to 12. Did you get the two items right? I hope you did. Thanks for watching, guys. This is Teacher Rejil. Keep safe.